next lesson with the expanding, so with the different types of expanding. And today we're going to do the opposite, which is factorizing. This is opposite to expanding. So we start with an example. So if we expand this, oops, Control Z, forgot to Control K. Okay. All right. So we're going to expand this and do -3 times x, which is -3x, and then -3 times 4, you get -12. So right, -12 minus 3x minus 12. Yep. And the same thing for the other one. You do -3 times x minus -3 times 4. Notice that there's a double negative, which becomes a positive. So you will get -3x plus 12. So this process is called expanding. Today we're going to do the opposite, going backwards, called factorizing. So let's factorize the first one. -3x minus 12. Now, this is just the expanded version of that, isn't it? So we're going to go backwards. So how do I go backwards? Is to go back to step 2. Step 2, so you write that as -3 times x, and then you write plus -3 times 4. Okay? Why do I put a plus there? Because I have to take the -3 out. Because -3 is common. So you write -3 and then open bracket x plus 4 equal -3x plus 4. Right, so exactly. So when you take a negative from both of the terms, the negative will become a plus. Okay? All right. Okay, let's move on to the next one. Same thing. 20a squared, you can write that as 10a times 2a plus 10a times 3. Can you see both of them has 10a, which you can factorize to 10a, open bracket, write down the leftovers, 2a plus 3. Yes? Good? Any question? All right, good. So let me, sorry, I just need to do something first. I think I forgot to, okay. All right. Okay, going backwards. All right, good. All right, let's continue. Next question. This one, you do not expand. Notice that there's a common factor as x plus 1. So we take the x plus 1 out, and then write down the remaining thing, so which is the 2 minus a. Yep. Right, pretty easy. Any questions? So these are the basic factorization, just taking out a common factor. And then we're going to go through the other type of expansion. Let's review this expansion. What's this going to become? What do we call that one? Yeah, let's write it down. So that's a difference of 2 squares. And let's repeat the expansion. You get a squared minus ba plus ba minus b squared. The 2 middle term cancel. That's why you get difference of 2 squares. And today we're going to go backwards. Going backwards, which is factorizing. Okay? So you'll be starting with a difference of 2 squares, because this one you can write that as x squared minus 4 squared, which is difference of 2 squares. So because of that, we can use the formula a plus b, a minus b. Your a is the x, your b is the 4, right? So you will write down x minus 4, x plus 4. Like that. Any question? How about the second one? The second one is a little bit more tricky. You have to write that as one thing squared minus another thing squared. So 9a squared can be written as 3a all squared, and the 4b squared can be written as 2b all squared. It's very important that you do this step first before you factorize. So So the question will become, answer will be 3a minus 2b, 3a plus 2b. Right, difference of two squares. So we're going to do 4 different types. So there's the simple one, slightly harder one, and part C requires 1 additional step. Now notice that 12 is not a perfect square. So what you need to do is you may have to take out a common factor. So we're going to take out a common factor. So do 1452 divided by 12. That gives you 121. So you can write that as 12y squared minus 12 times 121. So you can take out a common factor of 12 out. So sometimes you have to take out a common factor first, which is y squared minus 121. But 121 is a perfect square. So what square become 121? 11. So that's a difference of 2 squares. So you factorize that, which become, you can write the plus first, and then the minus second. Doesn't matter, as long as you have 1 plus, 1 minus. Okay, that's done. Part C, we have to take out a common factor. How about the next type? There's a bracket. Do we need to expand? The answer is no, you don't expand. You see that as one single term. Okay, so that's a slightly harder one. So that's x plus 3 squared, and then write the 4 as 2 squared. And then you're going to prepare yourself. Okay, so obviously 1 is a plus, 1 is a minus. That's too big. Okay, so 1 is a minus, so 1 is a plus 2, the other is minus 2. But for the first term, you're going to write down the whole thing, x plus 3. X plus 3. Does that make sense? X plus 3 plus 2, and then x plus 3 minus 2. Because x plus 3 is like your first term, your A. Right, so this is like your A, this is like your B. Right? And then you have to do one more step of collecting like terms. So 3 plus 3 is 5, and 3 minus 2 is 1. Yep. Any question? So that's factorizing difference of 2 squares. And we've got one more page to do. I think there's some harder ones. Next page. Okay, so we'll do some harder examples. Already? Let's move on to the next page. Thank you. All right. These are harder ones. These ones involve surds. We did surds in chapter 2. So 10 is not a perfect square, but we can write 10 as square root of 10 squared. Right? So that means I could factorize it. So it's going to be x minus, oops. It's going to be x minus root 10, x plus root 10. Like that. And same thing for the second one as well. 24 is not a perfect square, so you have to go x squared minus root 24 squared. Then it becomes difference of 2 squares. So x, like that. So x minus root 24, x plus root 24. But can root 24 be simplified? You can simplify, isn't it? So what does that become? Root, 2 root 6, which is 2 root 6. So we learned that last year in chapter 2, how to simplify this. So that's been useful here. Oops. Okay, so make sure you simplify the surd, but the 10 can't be simplified, so we leave it as it is. Okay, good. All right, done. All right, we've got another one. This is like the one we did before. When there's a square bracket, do not expand the bracket. You will just do it like this. So x minus 1 square, you leave it as a square, but you write root 5 square, like that. And then you have 2 brackets. 1 plus, 1 minus. So the plus, you root 5, and the one in front, you write down x minus 1, x minus 1. And there's no like term, so we'll leave it like that. So we can't add the 1 with the root 5, so we just leave it like that. Okay, good. Any question? And then we're going to do more harder ones. Okay, so we did this one, and then we're going to... Okay, all right. So the next type is, there are 4 terms. What do I do if there are 4 terms? You group in pairs. You group in pairs. So you're going to go between these 2 terms, x is common. So you write x minus 1. And with the last one, a is common. So you take the a out. So you group in pairs, take out a common factor between the first 2 terms and a common factor between the last 2 terms. And you'll see that there is a new common factor appeared. What's the common factor here? Yeah, x minus 1. And then the leftovers, you put it in the second bracket. Yep. Right, pretty straightforward. Very straightforward. So I think you'll be able to do the work very easily. Okay, we've got one more column to do. These are harder ones. So the question gets harder and harder, and there's a challenge question at the end. Okay, hopefully you finish. Yep. And then we'll do the next one. Factorize. So we have fractions. So what do we do? Fraction, we do exactly the same thing. This is not a perfect square. So you have to write that as x squared minus square root, the whole thing, but put a square on top. Then it becomes a difference of 2 squares, right? Make sure your square root is long enough to include the denominator as well, okay? So you're going to write x squared, x minus root 3 on root 4, and the other one x plus root 3 on root 4. So you can split the square root into 2 parts. The reason why I do that is because root 4 is 2, isn't it? So your final answer will be x minus root 3 over 2, x plus root 3 over 2. All right, let's do the next one. What do we do with the next one? Let's move to the right. Okay. Notice that they wrote the negative term first. So all you have to do is just swap the order. 8y squared minus 7. But unlike the previous one, there is no common factor. I can't take out any common factor. So that means I have to write that as root 8y all square, root 7 all square. Okay, so write it like this. So that's the trick you use today. Every time it's not a perfect square, put a square root, put a square, and then it looks like a square. Now before we do that, make sure you simplify the root 8. What's root 8 equal to? Root 4, root 2, which is 2 root 2. Yes, Charlie? Am I? Okay, all right, let's continue. So you write 2 root 2y minus root 7, 2 root 2y plus root 7. All right. Okay, done. Question. And then we've got another 2 to do. And there's plenty of time for you to do the work today. Right, again, there are just more different types of 2 squares. So 3 squared minus this. Right, 2 squares. So you prepare yourself. So once you do that, you write 3 minus bracket x plus 3. And then 3 plus bracket x plus 3. Notice that I have a bracket when there are 2 terms. There's a bracket here. Make sure you put it there. The reason why is there's an extra negative which you have to expand. Alright, so there's an extra negative you have to expand. So that means your next line of answer will be 3 minus x minus 3. Right? X minus 3. That's why there's a bracket. And the second one, no change. Just 3 plus x plus 3. Now you have to collect like terms. Okay? So 3 minus 3 is 0. So you end up with negative x. And the other one, 3 plus 3 is 9. So write 9 plus x is your final answer. Oh, oops. 6. Yeah, that's a very common mistake in exam, including myself. 6. Okay, thanks for that. Good. I think you should be able to try the next one. You've seen a lot of these examples. This is just a harder version. Okay, so like before, you write something. I think I ran out of space, so go like this, something times something. Okay, so you go x minus 4 in bracket minus x plus 3. Just like the previous one, it's like your A, that's like your B. And then the other one, x minus 4 plus x plus 3. Note the use of my brackets, because when you subtract things, you need to remove the bracket. Now you have to collect like terms, but remove the bracket first. So you go x minus 4 minus x minus 3 multiplied by x minus 4 plus x plus 3. And you collect like terms after that. And the like terms are the x, which gets cancelled. And the negative 4 minus 3 is negative 7 in the first bracket. In the second bracket, x and x gets added to become 2x. Negative 4 and the plus 3 becomes minus 1. Okay, yep. That one, this one, minus x minus 4, because that's x minus 4. I just copy down what's on the top. Yeah, I just write this again because my pen's not very good. It's very hard to write sometimes. So I just write it like this, x minus 4. Yeah. All right, done. Any question? We've got one challenge questions to do, and it's actually not as challenging as you think. Let's do that. Now, what do I do with 4 terms? What do we do normally? We have to group in pairs. Now, if I group in pairs, it doesn't work, isn't it? There's no common factor here, nor there's a common factor. So we have to swap the order of the terms. How should we swap it? Yep, maybe we'll try that. X squared plus 5x. Yeah, a sensible thing to do, maybe group the y's and the x separately. Could that work? It didn't work because this one doesn't work, isn't it? Yeah, maybe we should group the 5 because the x and y, they don't. Yeah, so doesn't work. So let's mix them together. We have to put the 5 together, maybe. All right, let's try to put the 5. So it's about experimentation. So if that didn't work, try another method. Maybe we'll group the 5. So write x squared minus y squared plus 5y plus 5x. Or maybe, yeah, like this. So group in this order, I think that will work. Now, how do I factorize x squared minus y squared? What would that be? Yeah, that's a difference of 2 squared we just learned before, right? And the second one, there's a common factor of 5. And we got this. Okay, now, is there a common factor now? All right, which one? Yep, they're the same, just different order. So you take out x plus y. And then write down any remaining terms. So what are the remaining terms? The x minus y and the plus 5. So it's not as challenging, but just you need some experimentation. You did very well today. Hopefully, to really learn this and understand this, you need to do the work. So you need to do the textbook work first. Now again, let me remind you, oh, it's not on there. Okay, so make sure you write down the date on your unit of work. We'll do exercise 8B today. Okay, thank you.